we were discussing about two port network, and one example I took that if the network, the two port network is known to be as simple as this. This is the 3 terminal port, number of terminals are 3, but input port are these two, there is a common terminal. So, this is V 1, this is I 1, but I should not play with the polarities that we have assumed to be consistent all the time. So, this is how a two port network is defined, and then we found for this network y exist, that is what I did. For this network I found y parameters can be easily found out. Instead of doing like this, you can because it is such a simple network, you write down these equations and cast it in this form I 1 in terms of V 1 V 2, I 2 in terms of V 2. So, y parameters exist, but then z parameters, if you wish to calculate z parameters, you must take the inverse of this y matrix. This is this one is the y matrix, is not, and we find determinant is 0. You have to divide all the elements with determinant 0, then they will, all the elements will blow up to infinity, and it is of no use to us. Another example let us take. So, this one we have considered. Now, another simple example let us take. For example, this you delete is this one, no? Can you delete? So, let us take another example. Suppose a simple example, it will give you more better understanding what really we are doing. Suppose you have a network like this, I tell you it is, and the two port network is known. Suppose I say there is an impedance between these two. This is no z parameters, it is the network itself, two port network. Here is the thing, and suppose I know inside it is z, I tell you, and I ask you find out the z parameters, comment on z parameters and about y parameters. You see this one is the convention I 1, and this one is the convention of the two port network. This I will be always maintaining like this, and I want to trying to find out z parameters of this network. And to do this, you can go from the definition that write down V 1 Z 1 1, but it is such a simple circuit. I will do it in a much simpler way. For example, if this is I 1, this is I 2, this current must be I 1 plus I 2, is not? And then I will say that V 1 is nothing but I 1 plus I 2 into Z. The voltage drop across Z is I 1 plus I 2 into Z. Similarly, V 2 is equal to also I 1 plus I 2 into Z. What else? I 1 plus I 2 into Z. And this one is Z into I 1 plus Z into I 2. And this one is Z into I 1 plus Z into I 2. So, B 1 B 2 like this, if you write in a matrix form, yes, impedance matrix is very much present, and which are Z Z Z Z, I 1 I 2. is not. And after I have got this, is it possible to express I 1, I 2 in terms of impedance matrix, in terms of the voltages? Then what you have to do? Z Z inverse into V 1, V 2. And I find the determinant of this impedance matrix is 0, and therefore, y parameters do not exist. That is the thing I wanted to tell you. Depends upon, see, the arriving at the particular parameters, whether it is z or y, if you can look at the networks which is very simple in nature, you can just by inspection straight away get it. You need not do all the time V 1 by I 2, V 1 by I 1 with V 2 equal to 0, draw the circuit, get, those things are not necessary, as it is so simple in types. In fact, if you are very good in circuit, you can easily make it out. So, this is the Z parameters and Y parameters I have talked about. Now, there is another parameter called hybrid parameters, and hybrid parameters. Of a two-port network. Is it? So, here what is done is these hybrid parameters of this two-port network are denoted by H matrix. Now, what it is? It also relates, suppose a two-port network is there like this, and here is your same convention V 1 I 1 and V 2 I 2, same network, and this can be written in terms of impedance parameters, it can be expressed I 1, I 2 can be expressed in terms of admittance parameters. Similarly, those are the basic equations. If we try to write down these quantities, that is, I will express V 1 as a function of I 1 and V 2. And this is H 21 I 1 plus H 22 V 2. Mind you, these are algebraic equations. I can manipulate them in this way and can express it V 1 V 2 in terms of I 1 I 2, or I 1 I 2 on one side and V 1 V 2 on the other side, then admittance parameters. And therefore, people say that okay, it is not, you take voltage of input port and current of output port and try to express it in terms of input port current and output port voltage, and then I will call these parameters like this. So, this is another way of one can express a same two port network either in Z or in Y, or so called in the hybrid parameters. Now, whether those parameters value will exist or not, we have seen how to also ascertain that. But right now, if it is what is the are the implications of these parameters? Let us try to examine. For example, under this condition, that is, I want to write down the input voltage and output current in terms of some parameter values there, in terms of I 1 input current and output voltage, a mixed up thing, voltage and current. Acha, let us see what happens to H 11. What will be H 11? H11 will be V1 by I1 with V2 is equal to 0. This is what it will be, V1 by I1 with V2 is equal to 0. How to find this out? That is, take the network, same network with which I should excite it, I1, a current source, I have excited I1, and then V2 is equal to 0, means it should be shorted. You know, V1 by I1 with V2 equal to 0 is H11. Therefore, this V2 equal to 0 you make and record this voltage. Then V1 by I1 is H11 parameter. It will be H11 will have an unit of omega, but means ohms, V1 by voltage by current. Is it equal to the driving point impedance of the jet parameters? That we will see and you can easily ascertain, but let us keep. So, H11 is this. Similarly, H21 from the same network with V2 equal to 0 will be equal to I2 by I1 from the second equation, I2 by I1 with V2 equal to 0. That is, do this experiment, short circuit the output ports, excite it with current source and record the current gain I2 by I1. H21 is dimensionless. In fact, current amplification sort of thing, I2 by I1, it tells you about that when the secondary is shorted. Similarly, so this is the H11, H21. What is H12? H12 will be equal to V1 by V2, V1 by V2, V1 by V2 with I1 equal to 0. Isn't it? If you make I1 equal to 0, then V1 by V2. So, what experiment you have to do? You excite the second port, output port with a voltage V2, you excite, this current is I2, but keep this open circuited, I1 is 0, OC, open circuit, and record this voltage V1 by V2 under this condition. H12 will be also a dimensionless quantity. It tells you the ratio of the voltages of input and output port. And from this you can also find out, from this experimental setup, you can find out H22 also. H22 will be equal to I2 by V2 with I1 equal to 0. That is from this experiment only. So, you measure this current I2 and V2 with I1 equal to 0, open circuit. This will be the it is not a dimensionless quantity, it is mho, conductance 1 over ohm. Therefore, you see it is a mixed up thing, all the parameter values are not having same dimensions, sometimes current gain, sometimes voltage gain and so on, but nonetheless it can be done. Okay. And so, this equation is therefore H11, H12, H21, H22. And if you wish the inverse relationship, can be also written like this: I1 V2, that is input port current and output voltage, port voltage, can be also written like this: H11, H12, H21, H22, and its inverse into V1 into I2. If this inverse exists, and these parameters are called, we will not discuss in detail, are called the inverse of H parameters, that is H21, G21 and G22. In the same way as we can find out the y parameters from z parameters and so on, and I can easily write down that expression, which I am not going to do. You have understood this from the previous knowledge. Therefore, this is the scenario of the H parameters representation of a two port network. Now, the question is when to use your representing a two port network, which one will be convenient, Z parameter, Y parameter or H parameter. Now, we know it depends upon the situation. Right now, I am not telling that, but these are the various combinations that input port voltage and input port currents and output port voltage and output port currents can be expressed. After all, these two are simple linear algebraic equations. Okay, after I have done this, let me also tell you about another, and this is called H parameters. So for three parameters Z and Y parameters and H parameters, these are extensively used by while solving networks with transistors, H12 is beta, things like that. We will see to it later if time permits. Now, another way of representing a two port network is done by what is known as ABCD parameters. And sometimes it is some transmission line parameter, transmission parameters, or simply written T parameters. Why it is called transmitter parameters will be apparent. See, suppose you have a two port network. Okay. What happens is this: first you suppose have a transmission line. Transmission line will have capacitances in parallel, then inductances in series, and a pi representation of transmission line could be like this. This is your sending end voltage, this is your sending end current, and this is the receiving end voltage V2. After this power is transmitted through the transmission line, output voltage is V2. And this is a typical say representation of a transmission line, pi representation. There may be T representation also, but I am just to explain the things I have considered a pi network, transmission line modeling. Now, so these two are the input ports, receiving sending end, and these two are the receiving end port, input port, output port, but output port is the receiving port, okay? And this is the sending end. which is input port, and this is the receiving end. Which is the output port of the network. Here also it is 3 terminals essentially 1, 2 and 3, 3 terminal 2 port network. Anyway, so this is the thing, but here in transmission line business what people are interested, here is a little difference in the convention. What is that convention? Is that while describing this current direction, it is taken in opposite I2. So far you recall that I while describing the Z parameters, Y parameters, H parameters, I always took this to be the current directions and this to be the polarity of the potentials of the input and output port, is not. But here in this transmission line modeling ABCD representation of a 2 port network, what is done? I2 is taken to be the current delivered to the load. Here what will be there? There will be some load after you receive the power, it is just coming, and that is how ABCD will be defined. So, you should be just very carefully noting what I am telling now. So, it is with this convention. So, there is a change of convention for ABCD parameters. Change note change of convention of current direction in the output port, current direction in the output port. And then therefore, while describing the network parameters in this form, what I will do, but for Z, Y and H parameters it was all same, I1 and I2 entering into the port. But here what we will be doing, this side remains same, this is V1 and this side this is V2, and instead of I2 coming, I will write like this. Clear? This is the convention for ABCD parameters. And then what is done is here that input voltage and output voltage and current are expressed in terms of input voltage and current, or input voltage of current, that is V1 is expressed as V2 I2, oh sorry, A V2, sorry, it is V1 is equal to A V2 plus B I2, and input current I1 is equal to C V2 plus D I2, and here I will write all positive here, and A, B, C, D parameters are defined. Alternatively, some people do like this, okay, this is I2 minus I2 they will write and follow the convention. I will be following this. Okay. So, for ABCD parameters, recall that I2 is to be taken outside, then ABCD are defined in this way. So, this is the thing. So, input voltage and currents are expressed in terms of output voltage and output port currents as a linear combination, and this is the way it is. Okay. Now, after we decide that I will write it in this fashion, then we can define A, B, C, D, how to find out ABCD parameters of this two port network, which is a suppose a transmission line. Okay. Now, let us see what is A. Let us try to understand. A is equal to V 1 by V 2 with I 2 equal to 0 from the first equation. If you somehow maintain I 2 is equal to 0, then A will be V 1 by V 2, and with I 2 equal to 0, similarly C will be I 1 by V 2 with I 2 equal to 0. Now, suppose I want to do experiments and find out in this way, this equation tells me to do. So, what I will be doing? I will take this network, and V 2 I have to apply. That means, here I have to apply a voltage V 2, and record this current and input this voltage. Whatever below, I have to excite with that. That is what we have learned from earlier. Okay. But then there is a problem. You see, you apply a voltage and still make I 2 equal to 0 is very difficult. How? So, what people do is this point needs some understanding from your part, the way how to apply a voltage and still claim that I 2 equal to 0 with that is all. I mean, it is difficult. But then what I can do is this, from this I come to know, okay, what is 1 over A? 1 over A will be V 2 by V 1 with I 2 equal to 0. And here lies the clue here. Therefore, in this way it is not possible to find out the value of A, but it tells you that okay, 1 over A is V 2 by V 1 with I 2 equal to 0. So, this suggests that you take this two port network, excite it with V 1 voltage with I 2 equal to 0, open circuit the other port and measure this voltage and take the ratio of V 2 by V 1, but it will not give you A, but reciprocal of A. But anyway, once I know 1 by A can be found out. You got the interesting point here. Therefore, A from this it tells me that okay, V 1 by V 2 with I 2 equal to 0, and so I will apply a voltage V 2 to the output port, and I have to measure this voltage V 1, but I am not sure what to do, because V 2 applied I 2 may not be 0, how to carry out these experiments. But from this we say that 1 over A is V 2 by V 1 with I 2 equal to 0, and then I am comfortable. Okay, this is the two port network, apply a voltage V 1, I 2 equal to 0 you are demanding. So, keep it open circuited, and I can measure this voltage V 1, this voltage V 2, take the ratio. Similarly, you see the C, instead of trying to do 1 by C is nothing but 1 by C is V 2 by I 1 with I 2 equal to 0. So, from the same experiment I will be able to calculate 1 over C, that is V 2 divided by, also record this current I 1. Same is the case with B parameters. How to find out B parameters? Let us use this space. On the same page, let it be. How to calculate B and D? B as it is, B will be equal to V 1 by I 2, V 1 by I 2, V 1 by I 2 with V 2 equal to 0. V 1 by I 2 with V 2 equal to 0. And so, if you want to do what this tells you, that take this 2 port network, excite it the output port with a current I 2 like this, because I 2 direction is like this for 2 port network, I mean transmission parameters. So, this is your I 2, excite it with I 2 and V 2 is equal to 0 and V 2 equal to 0. So, here once again a confrontation comes. You are connecting a current source between these 2 points of known value I 2, and I am not sure whether this voltage will become 0 automatically, difficult to achieve. So, what I will say then, that 1 over V, same equation, this get reciprocated I 2 by V 1 with V 2 equal to 0. And then it is very convenient, okay, what this tells you that, okay, take the network, excite it with this V 1, V 1, V 2 equal to 0, short circuit this and record this current, everything is fine. So, I 2 by V 1, take this ratio, but this is not B, it will be reciprocal of B and then B can be found out. Finally, the parameters D, in the same way it can be calculated. How to find out parameter D? D parameter will be is equal to I 1 by I 2 with V 2 is equal to 0. Here once again, if you excite this with a current source I 2, you cannot be sure that V 2 will be 0. How to do this experiment? No, difficult. So, 1 over D is how much? 1 over D is I 2 by I 1 with V 2 is equal to 0. Let us calculate that, and this is achievable. So, what it says that you excite the input port with a current source, I 1, that is what it says, short circuit these secondaries, V 2 is equal to 0 and record this current, and the ratio of I 2 by I 1 is going to give you reciprocal of D, hence D can be found out. Got the point? And also note that D will be dimensionless, just looking at the ratios. B will be that of impedance, B 1 by I 2 something and so on. So, it is also a mixed up situation, but the only thing is input parameters, very logical thing, okay, input voltage and input port current will be how much if I know V 2 and I 2. So, this is how the ABCD parameters will be found out, and I will request you to find out as I have taken earlier, if the transmission line is this simple, and in the next class we will discuss. Suppose this is V 1, this is a transmission line. In case of transmission line, I will denote I 2 to be like this you please remember, and this is I 1. Suppose the internally the impedance network is known, then what should be the ABCD parameters? That is what I want to find out. Now, to find out the ABCD parameters of this network, You need not do all the shorting this that, you try to see that first thing is V 1 for this network. What is V 1? V 1 this voltage will be nothing but V 2 plus Z into I 2, is not? This will be V 1. V 1 is equal to V 2 plus Z into I 2. One equation is obtained. What is the second equation? I 1 expressed in terms of output voltage and output current. What will be I 1? Same as I 2, nothing else. So, ABCD parameters of this simple network will be simply like this V 1 I 1, and here if you write V 2 I 2, what will be the thing? V 2 into 1 will come here, Z will come here, there is no V 2 in the second side. This will be the ABCD parameters of this simple transmission line. Yes, one could think in this way and find out, but for simple networks you can easily make it out how the parameter values will look like. We will continue with this in the next class. Thank you.